So this is going to be 4-1 beta. And for 4-1 beta, what I did was I took this picture from the old textbook. So we used this book for 10 years. And they didn't come up with a second edition. And part of the AP test is real data, and the data in the Statistics in Action book was out of date. So we upgraded to the book you have now, and I'm happy with both of them. But I was really happy with this. It's kind of like IKEA directions, the way they communicate sampling methods, okay? So here is their picture of an SRS, top picture. You're not going to find this in your book. Stratified random sampling is a different picture. Now you see the sample size in both cases at the top here is 6. What's going on? Well, suppose this was upperclassmen in the building, okay? Everybody except freshmen. So if we wanted to sample the upperclassmen, a simple random sample could end up with 3 10th graders, 3 12th graders, and 0 11th graders. It could happen by chance. If we stratify the random sample into classes, 10th, 11th, and 12th graders, and we pick 2 from each, we would be guaranteed representation of all the groups. Cluster sampling. So cluster sampling makes it a little easier to get your samples. So if we said, well, here we go with 4 classes: freshman, sophomore, junior, and senior. But again, we're going to ignore the freshmen. And this is just a snapshot, but what do you got here? You've got an entire advisory. So we pick an advisory at random, and we take the opinion of all those children in that advisory. And then we also had 10th graders respond, 11th graders, and 12th graders. So that's a cluster sampling. 2-stage cluster sampling is the same thing, except in taking the entire advisory, we randomly select children from the advisory that we picked. And systematic sampling of the random start, if you think back to the example in Alpha, which was the guidance counselor wanted to know how much sleep the children were getting, but the data that they collected was biased because they did a convenience sample. The convenience sample was just ask the first 100 children to walk in the building. So if we wanted to do this, if we wanted to get 100 children, and we wanted to use this method, we could literally lock all the doors and make everybody come in the front of the building, randomly pick someone. You could use your calculator. You could use the random digits table in the back. Suppose we randomly started at the 8th child, right? And we have 1,200 kids coming in the building. We want a sample size of 100. So we're going to start at 8 and then go every 12th child. Again, I know that's only going to be 99 children, but we have more than 1,200 in the building. But that would be systematic sampling. Every nth child after we randomly start. So that would be, that would come back, that would minimize the bias that we had in the convenience sample and trying to find out how much sleep the students got, okay? So, in the alpha lesson, sampling error. And the sampling error came from convenience sampling. That's 2 sources of it, not the only 2. Convenience sampling, voluntary response. All right, I'm going to put up, I just saw this, I could put a poll up here. I'm going to put a poll on canvas and say, how many people want Nick Foles back as the quarterback since he just beat Brady again and the Eagles are having issues? Well, it's a voluntary response, Paul. I mean, who's going to, the people that remember the Super Bowl are going to reply, or the people that think they're still in the Wentz wagon, they're going to reply. But it's not a sample that would represent how people in the building felt. That would have to be random, okay? And the beta lesson today is the resulting bias that comes from sampling error. Well, you could undercover, you would have non-response bias. Undercoverage bias would be if you were, you didn't get to the people. Like for example, in that convenience sample, you didn't get to the people that came in late. Well, a lot of them were sleeping less. Non-response, people ignore this. They just don't reply. And response bias, well, response bias is on page 234 of your book. It's a little gross, the example, but they say, they surveyed people and asked them if they wash their hands when they leave the restroom versus putting somebody outside the restroom, and they could tell whether people walk out there with wet hands, or they're walking out with a paper towel. And they said that there's a discrepancy there. Well, it's response bias. If you ask somebody, they're going to say, yeah, I wash my hands. That doesn't mean they're doing it. Okay? So those are all part of trying to minimize bias. And bias, again, is a definition you're accountable for. And you're accountable for two definitions so far. The definition of R squared, which was from Unit 2, so Chapter 3 of the book, the proportion of change in the output that can be attributed to change in the input. Bias. We can't have you looking this up. This has to be something that is familiar to you. Bias is when the sample statistic does not map onto the population parameter. You have that alliteration. Sample statistic with S's, population parameter with P's. Okay? So we're going to pause this, and you're going to go to two questions, 21 and 33. I just wanted to show you this. This document is in the resources folder of Canvas. This is the anticipated FRQ document, right? And we scroll through here. It's too early to go over this, but I just wanted to show you this. If I look back on 2013, so this has a grid here of the last 7 tests. Doesn't count last year. So last year was 2 questions that had multiple parts, okay? And then there were multiple versions of it. But this is, when they would give the same test to people. We go back to 2013 and look at question 2. It's exactly what we're doing. Part A was about bias. Part B was a simulation, which you did in the alpha lesson. And part C was compare sampling methods. So what you're doing today, this question 21, is an AP level question. If you want to, scroll through this, it's in there. It's in Canvas in that resources folder, but we're going to focus on this document in the spring after we get clarification about the test. So, 21, I'm saying this. There's 1,200 rooms, 30 floors, 40 rooms per floor. Half of them face the water, half face the golf course. Okay? You want a sample size of 10%, 120 out of the 1,200. So you should get 60 rooms facing the water and 60 rooms facing the golf course. And the way you could do this is you could get 2 rooms per floor. There's 30 floors. So if you had 2 per floor that faced, one faced the golf course and one faced the water, you would have proportional representation. Okay, if you took an SRS to get your 120, it would be very unlikely that you would get 60 of each. And the floors are different. Now you're going to have a better view from a higher floor. However, that would be really challenging to do that. It would take a lot of legwork. So you could use the floors as clusters. You randomly choose 3 floors. There's 40 rooms per floor. Well, it automatically give you 60 would face the golf course and 60 facing the water. So if you got this question, this type of question in May, they asked you to describe how to do the sampling. Well, these are both thought out ways to do this, right? 33 is about leading questions, right? Wording bias. Now, you don't have to name all the biases, but they're saying, does this make sense to you? Like A says, some cell phone users have developed brain cancer. Wow, you can tell where this person's coming from with the question, right? B, do you agree that a national system of health insurance? Wait a minute. Do you agree? Like, you're being channeled to say yes. You're being confronted by this person. And then in view of escalating environmental degradation, yeah, we know who that person's position is. So these are 3 ways to have more neutral wording. Okay, these aren't the best 3 ways to word those questions, but they're more neutral, which would more than likely give you more accurate sampling. Like you may have a rooting interest. I had somebody knock on the door last year. They were collecting data and they were wearing a vest, like I guess to identify what organization they were with. But I'm looking at the vest. I'm like, I can tell what you want me to say by looking at the vest. I wasn't interested in talking to somebody knocking the door either. But the point is, it's not like you're trying to get the information you want. You're trying to minimize the bias. And it's helpful no matter what your position is, because if you have accurate data, you can channel the resources, the places that you would need those resources depending on the accurate data, okay? Having people tell you what you want is not going to help you. So that's that for 4.1.